This is our third objective on Practice Test C, stoichiometry. We are to identify and use the limiting reagent in a reaction to calculate the maximum amount of product produced and the amount of excess reagent left over. Our first problem reads, vanadium 4-phosphide is produced from its constituent elements. Vanadium 4-phosphide is produced. I will point at vanadium. Roman numeral tells me it's a +4. Phosphide, who carries a -3, so when we crisscross, we get V3P4. The elements it's built from, vanadium and phosphorus. We will have 3:4:1 stoichiometric ratio, our balanced equation. The balanced equation is then used in letter B. How many grams of vanadium 4-phosphide can be produced from the reaction of 175 grams of vanadium and 100 grams of phosphorus? Since we are given information about both reactants, we know it's a limiting reagent problem. The target is our product. We'd like to know the maximum yield of V3P4 in a gram unit. I'll get my 3-step parentheses ready for the stoichiometry journey, knowing we have the same target, grams of V3P4. In our first conversion, we will need the molar mass of vanadium. Vanadium has a molar mass of 50.94. I'll just round that to be 51. In our first conversion, we would write 1 mole of vanadium over 51 grams of vanadium. In the heart of our problem, we want the product, 1 mole of V3P4 for every 3 moles of vanadium, a 1:3 stoichiometric ratio. The last step will need a molar mass for V3P4. Let me calculate. 51 times 3 on the vanadium plus 31 times 4 for the phosphorus. I get 277 grams of V3P4 in every 1 mole of V3P4. Let's hit for the maximum yield. I have 175, divide by 51, divide again by 3, times 277. I found 316.83 grams for my first reactant. Let's begin that second journey. Beginning with 100 grams of phosphorus, we have 1 mole of phosphorus set over 31 grams, the atomic weight of phosphorus. Canceling the gram unit and heading into the mole by using molar mass of P. We still want the target, 1 mole of V3P4, but this time using phosphorus coefficient of 4, a 1:4 stoichiometric ratio. We have the same third step conversion using the molar mass we calculated a moment ago, 277 grams in every 1 mole of V3P4. I hit 100 divided by 31 divided by 4 times 277, and I find 233.39 grams of V3P4. We were asked to solve for the maximum yield. The maximum yield is the smaller of our two answers. We can only make as much as the limiting reagent allows, so I'm circling the smaller of my answers. And I also want you to circle that you know phosphorus was the limiting reagent, therefore vanadium must be in the excess amounts. This helps me plot the journey for letter C. We need to calculate the grams of excess reagent left over. Excess means we poured in too much. If we started with 175 grams, we'll need to calculate how many grams of that were used and then subtract to find the difference, the wasted amount. Always begin your problem with the limiting reagent, 100 grams of phosphorus. We'll set up the 3-step conversion, targeting the excess reagent, the grams of vanadium. I want to calculate to the like unit that the excess reagent was started at so I can make my subtraction go easy. We'll use our divide, ratio, multiply with 3 steps to stoichiometry. In our first conversion, I used 31, the molar mass of phosphorus. We want over given, we want the excess reagent. Its coefficient is a 3 moles of vanadium, set over 4 moles of phosphorus, a 3 to 4 stoichiometric ratio. We'll use the molar mass of vanadium in our last step, 51 grams, set over 1 mole for vanadium. Starting with the limiting reagent, 100 grams of it, I divide by 31, times 3 divided by 4, times 51, and I found 123.39 grams of vanadium. Remember, that's the amount that was consumed or used up during our reaction. If we started with 175 grams of vanadium, and along the way we used up 123.39, let's find the difference, 175 minus the answer to our stoichiometry problem, 123.39. I'm finding 51.61 grams of vanadium were in excess amounts. The difference between what we started with and what we used gives me the answer to how much was left over.